HVAC contractors were surveyed by The News, a trade publication, about their primary concerns when choosing a room thermostat. The result? Quality, accuracy, and reliability topped the list. White Rogers, a leader in the HVAC industry since 1937, has listened for years to what the contractor wants and has developed the best room thermostats on the market today to protect your reputation. And while any thermostat supplier can say that, what separates White Rogers from the competition is the comprehensive testing methodology that backs up that statement. The majority of thermostat suppliers can't meet the standards engineered into White Rogers thermostats. The testing goes well beyond anything the thermostat would see in real life. Why do we test to such extremes? To ensure every White Rogers thermostat you install has the highest quality, reliability, and accuracy you and your customers demand. Are you aware there is no national standard a thermostat manufacturer must meet? The testing you are about to see is something White Rogers does voluntarily to ensure you get a thermostat that you can be proud and confident to offer your customers. If you aren't using White Rogers thermostats, ask your thermostat supplier what testing they use, and if they can show you first-hand testing as comprehensive as you are about to see. This secure testing facility houses millions of dollars worth of highly sophisticated test equipment. This is just one of 3 locations around the world where White Rogers tests its thermostats. The tests on our thermostats cover temperature accuracy to plus or minus 1 degree Fahrenheit, electrical reliability, thermal reliability, and mechanical reliability. Here you see a NEMA testing chamber. NEMA stands for the National Electrical Manufacturers Association. This is important because by testing in a NEMA DC3 type thermostat chamber, performance is certified to ensure optimum plus or minus 1 degree accuracy in temperature control. White Rogers has invested in multiple NEMA chambers at a cost in excess of $1 million to ensure our thermostats deliver the plus or minus 1 degree accuracy you have come to expect from White Rogers and your customer desires. You're going to view what White Rogers thermostats are subjected to in order to ensure the quality we and you demand. In order to simulate a thermostat being struck during a lightning storm, the thermostat is subjected to 500 amps on each terminal. As in any microprocessor-based system, electrical noise or transient burst can confuse the microprocessor. You may have seen your personal computer freeze when this occurs. The thermostat is pulsed at thousands of volts on each terminal, one at a time, to ensure our thermostats perform as expected. Here, the thermostat is subjected to well over 10,000 volts to simulate a static electricity discharge when touched by the owner during dry conditions. We life cycle test the touchpads to ensure their reliability. Here you see a test stand where 32 touchscreen thermostats are cycled hundreds of thousands of times to verify touchpad integrity. One would have to operate the touchpad 15 times a day for decades to reach this number of touchpad operations. You can see on the computer screen, some of the thermostats have in excess of 1 million cycles on their touchpads. HALT is an acronym for Highly Accelerated Life Test. Here we subject our thermostats to temperature testing from minus 100 degrees Celsius to temperatures in excess of 120 degrees Celsius. This is a minus 148 Fahrenheit to over 245 degrees Fahrenheit. During the HALT testing, we also subject thermostats to extreme vibration testing of up to 50 Gs of force. Again, these tests are purposely excessive. These temperatures and vibrations are well beyond what a typical thermostat will see in a home or when stored and transported in unconditioned spaces. Our philosophy is, if it can pass our rigid testing, then real-world use will be nothing in comparison. In this vibration test, the thermostat is vibrating so quickly it is difficult to see the movement. As a side note, a human being would pass out at 9 Gs of force. In this video, we test to over 3 times that amount of force. The purpose is to exceed the vibrations from shipping and transportation on a service truck and the potential of the product being dropped. Here you see a White Rogers thermostat in the HALT chamber before the testing begins. To test under the adverse conditions of minus 100 degrees Celsius to plus 120 degrees Celsius, the sensor in the thermostat has been locked to 76 degrees Fahrenheit in the heat mode and 71 degrees Fahrenheit in the cooling mode. These temperature extremes are well beyond the temperature range programmed into the thermostats, so the sensors must be bypassed and locked. This temperature simulation panel allows us to create a temperature change that initiates a call for heating or cooling. You will be looking at the LEDs identified as W1 and Y1. When the LED illuminates, it indicates a furnace or air conditioner operating. The purpose is to demonstrate that the relays in the thermostat are still operational, even after being subjected to the temperature extremes. The thermostat remains powered during this test. By introducing liquid nitrogen into the chamber, we drop the temperature down to minus 100 degrees Celsius, or minus 148 degrees Fahrenheit. The temperature in the halt chamber is now down to minus 100 degrees Celsius, which is indicated on the computer monitor. When we open the door to show you the thermostat, you'll see what looks like fog coming from the chamber. What you're actually seeing is a miniature snowstorm. The temperature in the chamber is so cold that it freezes the moisture in the air and causes a blizzard. As the snow clears, pay close attention to the display on the thermostat. As you can see, the thermostat LCD is still functioning despite temperatures well below anything it will be subjected to in real-world use. We're initiating a call for heating equipment operation. The W1 LED illuminates, indicating the heating relay has closed and a call for equipment operation has commenced. Even after being subjected to minus 100 degrees Celsius and 30 Gs of vibration, the thermostat is still operational. Now that it's past the minus 100 degrees Celsius freeze test, we're going to elevate the temperature to plus 120 degrees Celsius, or 245 degrees Fahrenheit. As you can see in this time lapse, the temperature is so great, we literally begin to melt the plastics on the thermostat. The question is, will the thermostat still operate even under these adverse conditions? As you can see, the LCD is still operating, but will the thermostat? When we initiate a call for cooling equipment operation, the Y1 LED illuminates, indicating the cooling relay has closed and a call for equipment operation is achieved. Again, successful operation in conditions well in excess of real-life temperatures. Why does White Rogers go to these extremes in our testing? To ensure you as a contractor get the highest quality thermostat on the market today, a claim we back up with continual testing like you saw here. It shouldn't be a surprise that White Rogers takes testing so seriously. In 1987, White Rogers was proud to become the first U.S. HVAC manufacturer to be agency certified to ISO 9000 standards. If you're not using White Rogers digital thermostats, ask your current supplier if they can show you how they test their thermostats. We have so much confidence in our products, we're proud to show you the testing and the data. Is the competition? For further information, you can view our website at www.white-rogers.com. White Rogers is a business of Emerson Climate Technologies. Emerson, consider it solved.